We're going to go ahead and discuss matrices, or introduction to matrices. So this is Algebra 2, Unit 2, Unit 5, Lesson 1. And I'm just going to go ahead and go through these notes with you guys. Okay. So a matrix is simply just a rectangular array of numbers in rows and columns. Okay. And each value inside the matrix is called an element. So these are some key vocabulary words that you guys need to know. Okay. And all matrices are denoted with a capital letter. So this is a matrix A, this is matrix B, and they're both capital. So we just got to be just a little bit of formality with matrix. Okay. Dimensions of the matrix tell us the number of rows by the number of columns. So each matrix has a dimension. So this has got 2 rows, 1, 2. So you write that first, and then 2 columns second. And it's always rows written first, columns second. Okay. So again, 2 rows going across by 2, 1, 2, 3 columns. So that's a 2 by 3 matrix. Again, this one, 1, 2, 3 rows by 1, 2 columns. So let's say 3 by 2. Okay. A column matrix only has 1 column, okay, and it's got 1, 2, 3 rows and 1 column. And just as we can have a column matrix, we can have a row matrix where we've got 1 row going across, but 1, 2, 3, 4, 5 columns right there. Okay, a square matrix has the same number of rows and columns, 1, 2, 3, 1, 2, 3. F is a 3 by 3 matrix. Okay, and each element inside there has a position. Okay, this one right here, pick on this one. This is in row 1, column 2. So that's got a 1, 2 next to it. Okay, this one is in row 2, column 3. So it's got a 2, 3 next to it. Looking down here, we've got, library, what's in circulation and what's in references. We've got books, magazines, and videos. So it says in the matrix, element 6000, which is right there, is in what position? Well, it's in row 2. It's in row 2, column 2. So 6 is in the position 2, 2. Okay. State the element in position 3, 1. Well, row 3, column 1, that's 2000. Okay. And what does that mean? Well, that's the number of videos in circulation at the library. Right? Videos, circulation, and everything is about the library. Okay. How many total magazines do we have? Well, we have 500 in circulation, 6,000 in reference. So the total number of magazines are 500 plus 6,000 is 6,500. Okay. So matrices. Okay, we can say matrices are equal if and only if they have the same dimensions and the corresponding elements are equal. So first of all, this is a 2 by 2. It's also a 2 by 2. And we want to say each element is equal. Well, this is going to help us set up just a couple of linear equations. We can say this element is equal to this element because they're equal matrix, so I can write it equal to, right here, 5x is equal to 10. Solve for that, we get a 2. Set this to equal to each other. Solve for y, we get y equals 3. Set this, 75 is equal to 3z squared. Z is equal to plus or minus 5. 9w is equal to negative 36. W is equal to negative 4. We'll just go ahead and place them there. And we can do the same thing right here. 3x is equal to 4y plus 13. 2x plus y is equal to 5. 2x plus y is equal to 5. I'm going to go ahead and rearrange it in standard form. Now I'm going to go ahead and solve this particular thing by elimination. I'm going to multiply the bottom equation by 4, leave the top one the same. I get this, I add, and the y's cancel out right here. So I get 11x equals 33, x equals 3. Okay, take that 3, plug it back into one of the equations, and then I get y is equal to negative 1. So x is 3, y is negative 1. Okay, over here, scalar multiplication. Scalar multiplication is pretty easy. You take a number which is on the outside of the matrix and multiply it to every element inside the matrix. So I'm going to take this k and multiply it to a, b, c, d, e, f. Things like this. Better example is right here. 3 is on the outside. We're going to multiply that into every element here. 2 times 3 is 6, times 4 is 12, times negative 3 is negative 9, times 3 is 1, times 0 is 0, times negative 2 is negative 6. Scalar multiplication. Okay. Addition and subtraction of matrices, okay, is very simple. We add element to element, in position to position. Now, but before we do that, we got to make sure they must have the same dimensions. If the matrices do not have the same dimensions, you cannot add or subtract them. So again, we just go ahead and add them. 2 plus -3, -1. -1 plus 4, 3. Okay. 0 plus 5, 5, and so on. We get that. Okay. Dimensions are the same. 2 by 3, 2 by 3. Okay. Matrix subtraction. Okay, you see that I made a few mistakes, and it's actually good that I did that, so I can show you. Okay, when we're doing subtraction of matrices, okay, you end up in a problem with a -3 minus a -4. Ends up being too many negatives. You kind of get confused. So what I would prefer that you guys do is add the opposite. You take this -1, which is actually a -1, and go ahead and distribute that -1 into this entire matrix using scalar multiplication. Then basically what you're doing is you're adding the opposite matrix. You end up with this. Okay, so I can say -3 plus 4, that's 1. Okay, so add the opposite, distribute that negative in, and then just add the two matrices together. Much easier to do. This one right here, this is a 1 by 3 matrix plus a 3 by 1 matrix. Well, the dimensions are not the same, so we have to say, well, we can't add them. Not the same dimensions, we can't do anything. Okay, over here, we've got a matrix plus some x matrix equals this. So what I can do is I can take this entire matrix, subtract it over, then distribute that negative sign in, and add the opposite to this to find out what x was. Or I can basically just say -3 plus what equals -3. Well, -3 plus 0 equals -3. -2 plus what equals 1? Well, -2 plus 3 equals 1. So again, you can subtract this matrix over, and then go ahead and distribute the -1, add the opposite to get this, or you can go ahead and say, looking for the what to get that. Okay, adding and subtracting with scalar multiplication, pretty easy. First of all, you follow PEMDAS rules. You multiply first, and then you go ahead and add and subtract. So you multiply 2/3 to every element inside here, we get this resulting matrix. And again, you can multiply by 2, then subtract. I would prefer you just multiply by -2 and add. So again, I multiply by -2 by every element here. I get this matrix, and I just go ahead and add element to element. Okay, position to position for the elements. 4 plus -6 is -2. Okay, and we get the resulting matrix right there. Now, application. What are matrices used for? They actually give us quite a bit of data. Okay, so this is just a little chart with the highs and lows for the 3 months of May, June, and July for the cities of Atlanta, San Francisco, and Anchorage, Alaska. Okay, so it's again, it says write a matrix for the average high temperatures in each city. So I can go Atlanta, San Francisco, Anchorage, May, June, July, and just get the high numbers: 79, 67, 54. Right that there. High for June is right here. High for July is right there. If I wanted to get the average low, again, set it up Atlanta, San Francisco, Anchorage, May, June, July, and get the low temperatures: 56, 50, 39, 56, 50, 39. Okay. Now it says write a matrix with the difference of the average temperatures. Well, the difference in Atlanta's May temperature was 79 minus 53 is a total of 23. Okay, and the difference is simply not a positive difference or negative, it's just the total difference between the high and the low. So just subtract them. Subtract here, get 20. Subtract here, get 18, and do that for all of them. And if I say which city and month has the greatest fluctuation of temperatures, we can say, well, Atlanta has got the biggest swing in temperature in the month of May. Okay, which one's got the least fluctuation? Okay, we can say Anchorage has got the least amount of fluctuation in temperature in the month of July, of an average of 13. Okay, I hope this was helpful. We have homework, which is page right here and right here. Okay, if you have questions, please come see me in class.